All right, as we move into Chapter 4, some things change. One of the things that we've been taking for granted is that triangles are congruent. No more is that the case. Now we are going to start to prove triangles are congruent. One of the ways we do that is by proving the sides are congruent. And this is called SSS, or side-side-side congruency. And there are about 5 different congruency theorems that you're going to learn. The first of those being side-side-side, or SSS. If you can prove that all 3 sides of one triangle are congruent to all 3 sides of another triangle, then you can say the triangles are congruent. Again, in Section 1, Section 2, we told you triangle blank is congruent to triangle blank. Set up the corresponding sides, set up the corresponding angles. But now we have to prove that triangle blank is congruent to triangle blank. Then we can do this. So this is just taking one step back. Again, so far you've been told that the 2 triangles are congruent. Now we're proving it. The reason that we can use side-side-side congruency is, let me get out my compass, my handy-dandy compass. What you're going to see here is that if I draw a triangle here, whoops, there's one side right there. Let me get out my thing to show you. Okay, there's one side of the triangle. Now let's pick a random length for the second side. Whoops, that wasn't supposed to happen. Let's try this. Let's go with that length right there. And now we're going to bring this guy up, and we'll give it a little tick mark right there. Now, you'll notice that the second side could be anywhere along that arc. Any of these lines could be the arc. In fact, it could even come way down here. What determines the length of the third side, or the second side, is where the 2 sides cross. Okay? Again, this side could be any along these. You'll notice that the closer they get to right here, that's where we get our second and third sides, is where those 2 parts intersect. And so, if the first 2 sides are already established, like, for example, if AB is congruent to RS and BC is congruent to ST, then the third sides have to be congruent. And we've already talked about this. We talked about third angle congruency. Third angle congruency, how if 2 angles are congruent to 2 angles, then the third angles have to be congruent. It's the same thing with sides. If 2 sides of one are congruent to 2 sides of the other, then the third sides have to be congruent. And if all 3 sides are congruent, then we can say that the 2 triangles are congruent. And that's called side-side-side congruency. Here, let me get rid of this guy because we don't need him anymore. We're told to find the coordinates of the 2 triangles congruent to triangle XYZ. So, what we need to do first is find the length of the 3 sides. If X, let me get a different pen color. If X is at -1, 3, and Y is at -1, 1, and Z is at -6, 1, we need to find the length of those 3 sides. Now it's very, very simple. When you're given a graph like this, we can count. XY is 1, 2 lengths. YZ is 1, 2, 3, 4, 5. We can't, however, count XZ or ZX. We have to use the distance formula. We practiced using the distance formula earlier in the chapter. X2 minus X1 squared plus Y2 minus Y1 squared. Well, if we're finding XZ, we need X and Z. I'm going to label X as my X1, Y1, Z as my X2, Y2. Make sure you're paying attention. Otherwise, as I'm saying these, you're going to get lost. And so when I write my distance formula, I'm going to replace all these. x2 is negative 6 minus x1, which is a negative 1, and square it. Plus y2, which is 1, minus y1, which is 3, and square it. Now I'm going to simplify this. Negative 6 minus a negative 1 is the same as saying negative 6 plus 1. Negative 6 plus 1 is a negative 5, and we have to square it. 1 minus 3 is a negative 2, and we have to square that. Negative 5 squared, or negative 5 times negative 5, is a positive 25. Negative 2 squared, or negative 2 times negative 2, is a positive 4. 25 plus 4 is 29. Now, question, can that be reduced? Answer, no. That is a prime number. That is as reduced as we can get it. xz is the square root of 29. Well, we need to find a triangle that is congruent to that size. You might be saying, how? It could be anywhere. You're right. Really, all we need to do is find a length of 5, a length of 2, and that third length will always have to be the same. And I'll show you what I mean. Let's grab any point. Let's grab this point right here. We'll call that A. I'm going to grab a length of 2, 1, 2, and call that B. Now, this side is the same as this side. AB is the same as YX. Now I need a length of 5, just like ZY. So 1, 2, 3, 4, 5. Come on, all together now. You can do it. Come on, you can move. I don't know. There we go. It's like my pen got scared and it froze. There, and we'll call that guy C. That's just, CA is just like ZY. Now, if I connect these two, I should get the same length as XZ. Now, what I'm going to show you is what I was talking about the third sides. If this length is 2, which it is, I can count, and this length is 5, this length has to be the same as this length. Let me show you what I'm saying. If this side is congruent to this side, and this side is congruent to this side, then this side has to be congruent to that side. And I'm going to prove it to you. I can see right away that the blue sides are congruent. They're both 2. The red sides are congruent. They're both 5. Now I'm going to prove to you that CB and XZ are both the square root of 29. C is at 3, 6. Or excuse me, 3, 7. B is at 5, 2. I'm going to use these 2 points and the distance formula to find the length of CB. I already found the length of ZX, found it as the square root of 29. CB should be the same length. You might say, how? Because if ZY and CA are the same length, and XY and BA are the same length, then the third sides have to be congruent. So I'm going to take my, and I didn't label them yet, just a second, sorry. X1, Y1, X2, Y2. I'm going to go through and substitute everything in. X2 is 5 minus X1, which is 3, and square that, plus Y2, which is 2, minus Y1, which is 7, and square that. 5 minus 3 is 2, and we need to square it, plus 2 minus 7, which is negative 5, and we need to square that. 2 squared is 4, plus negative 5 squared, or negative 5 times negative 5, is positive 25. 4 plus 25 is 29, still under the radical, square root of 29. So I've proven that the three sides of one are congruent to the three sides of the other. Now I can say that triangle XYZ is congruent to, now pay attention to this, how am I going to label my new triangle so that corresponding sides line up? The first thing that I labeled was XY. What side corresponds with XY? And the answer is BA. Which means that YZ comes next. What side corresponds with YZ? AC. So my triangle that corresponds with XYZ is BAC. XYZ, BAC. See how all the corresponding sides line up? Now I'm told to find the coordinates of two triangles. I found the coordinates of one triangle. Now I need to find the coordinates of a third. Well, really all I need is a side of 5 and a side of 2. And then that third side will always be the same. So I'm going to pick one way down here. We're going to pick this point, and I need a side of 5. 1, 2, 3, 4, 5. And a side of 2. 1, 2. And if I connect the dots, I have a triangle, and we're going to label this one R, S, T. This triangle, with this side of 2 and this side of 5, this side should still be the square root of 29. Now I need to figure out how am I going to write that as a congruency statement. What side of this new triangle corresponds with triangle XYZ? Well, the first letters in XYZ are XY, so we're talking about this side. What side of this triangle corresponds with XY? And it's RT. Or TR, excuse me. Come on. You can do it. TR. Then the second side we talk about is YZ. YZ. What side corresponds with YZ? It's RS. So triangle TRS corresponds and is congruent to triangle XYZ. Why? Because of side, side, side congruency. All three sides of one are congruent to all three sides of the other, which makes them congruent. And you can use the distance formula here. If you're really, really good, you could use the Pythagorean theorem, but you'll still get the same answer. We use the distance formula to prove that the third sides are congruent. Now, we didn't need to use the distance formula on the other two sides because we can just count on our graph. We can count 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. And then we use the distance formula to find the length of the third side. But once we've proven that all three sides of one are congruent to all three sides of the other, then we can say that the triangles are congruent. Remember, come on. So far, we've told you the triangles are congruent. Now you have to prove the triangles are congruent. Before you can say that triangle blank is congruent to triangle blank, you have to prove that all three sides are congruent. We just did that. We proved all three sides are congruent. Now, this is your turn. Let's take a look at your homework.